Now in question 9a, you've got the function of something looking like y is equal to a the minus x, which is seen before. And in addition to that, we've got a plus 1, or a y is equal to 1 as my horizontal asymptote. So by doing your initial sketching, showing the translations, so a to the x, a the minus x, and then elevating that by plus 1, gives you a very, very good idea of what your function's going to look like. By all means, test it on your calculator, but always pays to do an initial rough sketch. Now the y-intercept, when x is equal to 0, so that becomes y is equal to 5 to 0 plus 1, which is 2, 0, 2. We've got our horizontal asymptote. That occurs when y is equal to 1. Now, I haven't got an x-intercept, so I'll find another point. So another point occurs, say, when x is equal to negative 1. So that will give me a total of 6. So therefore, 1, 6. Sketching up my graph totally obeys my original hunch. There's a horizontal asymptote. I've got 0, 6. Sorry, 0, 2, I should say. And I had negative 1, 6. So my graph looking like so. In the case of 9b, if we look at the graph of a to the x, we've got our normal exponential growth. If we take the opposite of that, negative a to the power of x, we'll have it reflected around the x-axis. If I have an asymptote of positive 1, that's what my graph's going to look like. So I'll put in that information first. The horizontal asymptote occurs when x is equal to 1. Now, it seems unlikely I'm going to have a y-intercept, but I'll just quickly check that. So, sorry, an x-intercept is not 0. So I've got the origin being cut. So I won't have a separate x-intercept. It's the same thing. I'll try plugging in for a second point when x is equal to 1. So I've therefore got the point 1, negative 3. So I've got enough information to be able to sketch my graph now. Put my horizontal asymptote in at y is equal to 1, the origin, and 1, negative 3. Like so. As you do these questions, particularly early on, make sure you're checking them on your graphics calculator.